So unfortunately it's raining a little, but I'm actually at Hampshire Piano Rebuilders right now to ask some experts about the construction and engineering of the piano. Let's go. So here we have the soundboard of a Blüthner piano. Could you please tell us how exactly a soundboard works?
Okay, well, it's a little hard to see, but the ribs running across the underside of the board, the whole thing is actually held up in a slight bubble going the other way. And that bubble is supported by this sheet of wood actually expanding. And before they put the soundboard in, it's actually bowed up into a pretty strong arch.
And how's this done exactly?
Well, this panel is heated up to just period about 160 degrees, and the wood would shrink across the grain, and because it loses the moisture. Once it's down small, they glue the ribs across it, and it fixes the dimensions of one side of the panel.
Right.
And when it takes on moisture again, this upper board must expand.
Right.
And so it overpowers the ribs.
So it creates a bubble,
Yeah.
essentially.
All right, and when you take that and glue it in all the way around the rim, you get basically a three-dimensional spring.
What you just heard was by Craig Hare, who has been restoring pianos for decades, and his workshop has produced some of the best sounding pianos I've ever heard. To simplify what was just said, I would like to show you a vertical cross section of a grand piano. Here we have a soundboard, as well as the bridge and the string. So after being struck by the hammer here, the vibration goes along the string and is picked up by the soundboard through the bridge. Now, normally the vibrations from the string propagate across the soundboard. But there is something called a crown, which essentially is just a bulge in the wooden soundboard itself, which adds certain properties to the sound. This soundboard is also the bubble that Craig was referring to earlier. Let's hear what Craig has to say about the crown and what that does to the sound.
And that bubble then has an upward resistance that then has the capacity to resist and push back against the strings.
Right.
So between the strings pushing on the bubble and the bubble pushing back on the strings, you get this active tension that if the strings disturb the board then kicks back against the strings.
Right.
And that little interaction is what gives you sustain. Because the board doesn't eat all the energy at once out of the string. And while the string is feeding energy into the board, the next oscillation instant later, the board's kicking a lot of energy back into the wire.
I see.
So that it comes back, and through that efficiency, you get volume and tone louder than if this was just a flat sheet of wood.
Now let's hear the difference of a soundboard with and without the crown. I would like you to also pay attention to the decay of the sound profile on the lower part of the screen. The top profile is of the sound produced without the crown. As you can see, sound drops very quickly. There is also far more noise in the outline of the profile, as you can see here with these jagged surfaces. The middle profile is of the sound produced by a continuous crown. The sound drops slowly with a longer sustain. There's also far less noise, as you can see from the much smoother surface here. And finally, the profile on the bottom is with intermittent crowning every now and then. This demonstrates how the crown essentially acts as a signal booster for the volume, sustain, and signal to noise ratio. Also, if you look closely at the profile, you will notice that there are two peaks every time the makeshift soundboard is crowned. This indicates that one can over-crown a soundboard past an optimal point. Each time the board is curved, it reaches said optimal point before going past it. When it is released, it briefly crosses the optimal point once more. I hope you enjoyed this short explanation of how a soundboard works. I thank you for watching.